Today's goal is to get this here unit belted up so that I can cut the hub off of the windmill main shaft and then drill it out on the drill press. So this machine's been sitting here a while, restored it the past winter, but it hasn't been permanently belted. Part of that is because I wasn't sure if I was going to keep this pulley on it. It turns out the speed is pretty nice, so I'll keep it. But the shaft, because this was originally meant, this specific one was meant to be run by electric motor, the 1-inch shaft, the driven shaft, is not as long as it should be for a flat belt pulley hub. It is meant for a V-belt pulley hub, which is much more narrow. So hopefully I will be able to get it fired up and then use it to shorten another shaft that I can then replace this inner drive shaft with. So the line shaft spins, how would that work? Counterclockwise in this regard, so like so. And based on this arrow, that's good. I want it to turn the same way, but this is a reduction. This is a spur gear reduction hacksaw. So that means that the driven shaft will need to spin opposite to the main line shaft, which means I need single twist in the belt. So I'll show you how that works. By the way, you can see over here, this is how brand new flat belt comes. This comes from a company called McMaster Car, and it comes in a big loop like this. This is a whole bunch of 2-inch. It's not all for me, but I have enough here and from past times to cut some and lace it to this pulley. So I'll show you how this works. Basically what we're going to do is copy this pulley and belt here with the twist that goes there, but more of a vertical orientation for this setup. So what I've done is, this is my piece of belt from last time, and I want to use the new stuff this time, but not cut off a length before knowing. So I've gone ahead and laced both sides of this belt with the clipper and laced the one exposed end of the big belt. So all I'm going to do is throw this one up and over and have a pin. I'll take this and put it in place. Put the pin. Now I have this, and I know that this belt is going to come and bind, but or laced together, I mean. As I mentioned before, there has to be a twist to run this belt in the opposite direction. So if how do I do that? I'll just pretend it's going straight down and then grab it, kind of pinch it in the middle, and spin it so that the bottom is twisted. Give myself a bit more slack. Like so, and now I'll put it over the pulley. And the thing is, in my shop, the floor is gravel, and all the machines sit on pieces of wood, and pieces of wood sit on the ground. So really, it's only the weight of the machine holding the machine in place. So if I want to loosen the tension, for example, I can just move the machine a bit. If I want to tighten it, I can move it a bit, but the vibration will end up moving the machine to where it slacks, which is fine because these jobs aren't that big, but that's just something to note, because if your machine is bolted to the floor, to a cement floor as it should be, it won't move, and that'll mean that you can put a lot of tension in your belt from the start. So this shaft is only about 1 3/16 or something like that, and I already am about 2 feet from the hanger, so I don't want to put too much of a load right here because it'll make the shaft deflect. So no big deal. This tool doesn't draw that much power. I'm going to, yeah, so that's fine. So I'm just going to pull it tight, this top one here and the bottom one coming from the machine, and there's my reference point. It's pretty slack, so what I'll do is I will cut this belt 1 inch from the measurement. When I pull it tight like this, I'll score it here, and then I'll cut 1 inch so that that 1 inch will be used to tension the belt, and then I'll lace it, and I'll show you that right here. Okay, so here's the laced end of the long belt, and here is the marking from back at the machine. So what I will do, I told you I'll take off about 1 inch, so that's 1 inch on the short part, which will bring us to right about here. So with that as my reference, I'll take this square and line it up, kind of line the belt up going down with the square. Okay, that's good there. I'll just mark it. Score it straight across. And I've found that the nicest way to cut this stuff, this is from McMaster Carr, this belt is. It's, I believe they call it extended duty belt, but it's the cheapest stuff, at least for this 2 inch. And this is 3-ply. I believe you can get 3-ply, 4-ply, and 5 or 6. The price goes up a little bit each time, but this, for what I'm doing here, is plenty. So that's scored. I've tried to use tin snips before. They'll work, but they make a bit of a mess of the edge. Also used a big shear, but that's very hard to keep it square. So I just have these antique, very, very sharp scissors, and they do a fine job. The other way, you can, of course, lay it flat and use an X-Acto knife a few times, but these scissors work pretty well for me. It takes a minute because you have to kind of walk them through it. There we go. Good. So next is the lacing. So it doesn't really matter which side you used, but I've noticed on this belting, one side has, it's more flush. The weaves and the rubber on the inside are a bit more flush, and then the other side is a bit more ridgy. So I imagine that's the process when they were making it. One side was down against the table and one side was up. It'll work either side. It still has good traction, especially if you add belt dressing. So I have this little piece of clipper lacing here. This is still made, also available through McMaster Carr and other industrial suppliers. This is what it comes in. A foot strip, and I believe there are 12 or 10 strips in a box you can buy, and the numbers vary. So I've just taken those sharp scissors again, gone here, marked it, kind of held it with my thumb, and then used the scissors to cut the material out of the way. If you try to use an X-Acto knife in this case, just because of how the force goes, generally you'll push the material and it'll pop the clips out. So I really suggest scissors. So I'll grab the lacer, pop it all the way open. There's your retaining pin. So the machine says do all lacing in center of lacer. That's so that you get symmetric force when you, because you can apply a little bit more on either side. So I'm going to put this in, kind of push it back, put the pin in, feel some resistance. Now I know those are stuck in place. And you kind of, it's a bit hard to do this while keeping the clips how they should. If you take the top off first, for example, that's the easy way, but then when you go to lift the bottom, it'll pull the clips kind of up and out of alignment. So if I'm doing that, I just use a pen or something to keep all the clips downwards. There you go, that's out of the way. And use the pen, push them forward, and that's fine. So I tend to make the nicer side that I want to be contacting the pulleys up, because it tends to make the lacing more flush on the side that's facing up. The bottom will have a bit more ridges exposed. So just going to put that in there as square as I can make it. Bring the machine down, and now this is kind of where it's difficult if you're one-man operation. Sometimes I'll use my arms to apply equal pressure, and you'll see some guys put springs in the center here so they come back up after you've put them down. Sometimes I even use my head as one side, and all you need to kind of do this is until the lacing grabs the belt, which I see it has now done. So I can let go of it with this hand and use both hands. And so every time I drop, I pull the whole thing forward a little bit, and there's like a gear, what would you call that? A ratchet, I guess, that advances, that tilts the whole head a little bit, one notch every time. And you'll hear that, and it'll be very obvious when it's completely squished. Right there, it got much harder. So normally I'll just give it a couple cranks like that, grab that ratchet, flip it out of the way, take the pin out. There is the lacing. So sometimes that's pretty good. Sometimes if it's a bit more rough, you can take it to the anvil and just hit along here gently. So now let's install it. This is how it would run if it was a straight belt, and if I just twist one side, this is how it would run if it had a half a twist. So we'll line up the lacing, and I have the pins in my hand. One side. The other side. Okay, make sure it's on this pulley. I can roll it onto the top one. Whoop. There we go. Oh, whoops. Forgot to tighten the pulley on the line shaft. Okay, there's that. Looks good. Let's try it out. Good, it's tracking well on both pulleys. That's nice. You're rubbing a little bit right here. Get you a better angle. Automatic shut off. try to cut something for fun. Go, how's that? So, hope you enjoyed, and see you next time.